My dear students, in my previous video, I have solved some problems in the topic real life applications of conics. And in this video also I am going to continue the same application problems. In the exercise 5.5, there is a problem 3, application problem under parabola. The problem is, at a water fountain, water attains a maximum height of 4 meters at horizontal distance of 0.5 meter from the origin. See, it's a water fountain. Water flows like that. The water flows in the parabolic form. This is the flow of water. The water flow attains a maximum height of 4 meters at a distance 0.5 meter from the origin. So this is the origin. From this point of origin, at the distance of 0.5 meter, the water flows attain a maximum height of 4 meters, and it is of the parabolic form, and it reaches the ground. Now, what is the height of the flow of water? This height they are asking. And what is the height of the water when it is at a distance of 0.75 meter from the origin? When it is at the height 0.75 meters from the origin, what is the height of the flow of water? That is the problem. So since this is a parabolic path, the flow of water is a parabolic path and it is open downward, therefore equation of the parabola is equation of the parabola. This is exercise 5.5 in your textbook. Problem 3. So vertex is shifted to origin, the vertex shifted from the origin at the point x coordinate is 0.5 meter, y coordinate is 4 meter. So the equation of the parabola, and it is open downward, its form of the equation is x minus h the whole square equal to x minus h the whole square equal to equation of the parabola minus, this is open downward, minus 4a into x minus h whole square equal x square equal to minus 4a will form. So x minus h whole square equal to minus 4a into y minus k. This is the equation of the parabola. Since this parabola vertex is 0.5, 4, this h is 0.5 and k is 4. Therefore, this equation can be expressed as x minus 0.5 whole square equal to minus 4a into y minus 4. K is 4. Okay. This is equation of the parabola. This parabola is passing through the origin. See, the point, this is the parabolic curve, it passes through the origin. Therefore, this parabola passes through the origin. Therefore, substituting x equal to 0, y equal to 0, 0 minus 0.5 is 0 minus 0.5 whole square equal to minus 4a into 0 minus 4. X is 0, y is 0. So 0.5 whole square, on squaring you get 0.25 equal to minus 4a into minus of minus plus 4a into 4. This is minus becomes plus 4a. Minus into minus plus 4a. So therefore 4a equal to 0.25 by 4. This is the value of 4a. So from this equation of the parabola we get 0.25 by 4. Value of 4a. Now we have to find out the height of the flow of water at a distance of 0.75 meter from the origin. For that, our required question is we have to find out the height of flow of water at a distance of 0.75 meter from the origin. What is the height of the water? PQ they are determining. PQ is the height of the water at a distance of 0.75 meter from the origin. You consider PQ by Y. Therefore, Q 0.75 comma Y is a point on the parabola. Therefore, you substitute in the equation x minus 0.5 whole square, x minus 0.5 whole square equal to minus 4a into y minus 4. This is your equation. You substitute x for 0.75. So 0.75 minus 0.5 the whole square equal to minus 4a. You know, 4a is minus 0.25 by 4 into y. You don't know y. We have to determine y. Y is as it is. Y is 4 itself. So 0.75 minus 5. What do you get? 0.25 whole square equal to, you multiply by 4, this is 4 into 0.25 whole square equal to minus 0.25 into y minus 4. Okay? We have to determine the value of 0.25. You can cancel on 0.25 on both sides. 4 into 0.25 equal to minus of y minus 4. Simplification, 4 into 0.25. What do you get? This is 4 into 0.25 is 1. Just 1.00, that is 1 you have, minus y plus 4. You bring this y this side, left hand side y becomes positive, and 4 on the right hand side, and you take that 1.00 is 1, it is minus 1. So 4 minus 1 is what? 3. So y equal to 3 meter. So this is the height of the water flow is 3 meter. So the height of the water flow at a distance of 0.75 meter from the origin is, height of the water is the required height of the water is equal to 3 meter. Answer. That's all about the problem. This is the height, required height. Okay? This is problem 3. Next in the problem in the exercise, fifth one. Fifth problem also in the exercise, a parabolic problem. A parabolic cable of a 60 meter portion of the road of a suspension bridge are positioned as shown below. Vertical cables are to be spaced every 6 meters along this portion of the road bed. Calculate the length of the first two of these vertical cables from the vertex. See the fifth problem in the exercise. See, on your roadbed, there is a suspension bridge. It's in the form of parabolic curve. So this is the road bed. Good. This is the bridge, suspension bridge. You consider this as y-axis and this is as x-axis and this is your vertex, and the road bed of width is 3 meter. Parabolic cable of 60 meter portion. This is 60 meter. Parabolic cable of 60 meter. This cable is 60 meter. Portion of the road bed of a suspension bridge are positioned as shown below. So the picture is in the textbook, therefore it is given as shown below. Vertical cables are to be spaced every 6 meter along this portion. So some cables are supporting cables are there every 6 meter. Some cables are supported. Like that, every 6 meter. This is your 60 meters width. The suspension bridge, you need not join this line also. This is a suspension bridge. Cables are supported like that. The suspension cable is supported by some vertical cables, each of it at a distance of 6 meter distance. Similarly, here also some cables, the distance between those cables is 6 meter gap. So total width of the road bed is 60 meter, and also what is given. This is a 16 meter height pole. This is of meter 6, this is 13 plus 3, totally 16 meter. The extreme pole is 13 plus 13 meter. Okay. Now they are asking to find out what is the first two. Calculate the lengths of first two of these vertical cables from the vertex. First two cables, heights of first two cables are to be determined, VG. See, this is, you consider this as first cable by G and H. GE one cable and FH for one cable. So GE and HF are the two cables. So they are asking to find out the heights of these two cables and each of the distance 6 meter gap. Here on 6 and it is also 6. Okay. It's also a parabolic cable open upward. Therefore, equation of the parabola is x square equal to 4ay. The equation of the parabola is open upward and symmetric about y-axis. Therefore, this is problem 5 in the exercise. Equation of the parabolic cable. Equation of the parabola. X square equal to 4ay. This is the equation of the parabola. X square equal to 4ay. See, this distance 30, this is 30 and this distance is also 30. 60 is divided into two equal parts. The middle part is 30 and 30 meter. So the coordinate of this point is, x coordinate is 30 y coordinate is 13. This is 13 y. 30, 13. So y coordinate is x-axis, above the roadbed is x-axis 13, y coordinate is 13, x coordinate is 30. So the point, you consider this as AB. And you C, coordinate C, 30, 13 is a point on the okay. C 30, 13 is a point on the parabola. So you substitute x equal to 30, 30 square equal to 4a into y is 13. So 30 square by 13 equal to 4a. 30 square by 13 equal to 4a. Now we have to find out the heights GE and HF. We have to find out the heights of the two successive cables from the text. So coordinate of the point E is 6, y1. You consider coordinate of E is 6, y1. Similarly, HF, this is y2, you consider this is y2. V 6 plus 6, 12. F is 12, y2. These are the 2 points. See, GE and HF are first two cables, are first two cables from the vertex. So we have to find out the height of GE. We have to find height GE and HF. Consider GE by y1. Consider GE equal to y1 and HF equal to y2. Consider GE equal to y1 and HF equal to y2. First 6, y1 E. Substitute E 6, y1 is a point on the parabola. Is a point on the parabola. X square equal to 4a. 4a is 30 square by 13. 4a is 30 square by 13. X square equal to 4a y. The point 6, y1 is a point on this parabola. X square equal to 30 square by 13 y. X equal to 6 square equal to 30 square by 13 into y1, y forward. From this we have to find out y1. What is y1? y1 equal to 6 square is 36 into 13 by 30 square. 6 square is 36. Therefore y1 is 36 into 13 by 30 square is 900. So this is equal to 36 into 13. You will get, simplifying you will get 0.52. On 36 into 13 divided by 900 is 0.52, that is y1. We want the total height of the cable from this roadbed also. You have to add these three also. This is 3 meter. So total height of the cable (3 plus 0.52) equal to 3.52 meter. This is the height of the first cable. Okay. Similarly, second cable, HF plus this road bed height is also required. For the second point, 12, y2 is a point on the parabola. Next, you consider this is our first y1, this is y1 plus 3.52. Next, f 12, y2. Next case, the point f 12, y2. 12, y2 is a point on the parabola x square equal to 30 square to 13 y. Instead of 6 square, you got 12 square into 13 square y. 13 square will be 13 into y2. Therefore, y2 equal to, you bring this y2 here, on cross multiplying y2 equal to 144. 12 square is 144 into 13 by 30 square. That is, y2 is value of y2 is 144 into 13 by 30 square is 900 equal to this is, you get 2.08. The simplification will get 2.08 meter. Therefore, total height of the next cable is 3 plus 2.08 meter, that is equal to 5.08 meter is the second cable height. The cable of the second cable is, height of the second cable is 5.08 meter. That's all about the problem. This is the fifth problem. We have determined the two cables. First one is 3.52 meter. Second cable is 5.08 meter. These are the answer for the problem. This is our fifth problem. And one more problem I am going to solve. That is next problem, eighth problem. We will see the eighth problem. It is also a simple one. We will see. Eighth problem in the exercise. Assume that water issuing from the end of a horizontal pipe of 7.5 meter above the ground level, it describes a parabolic path. See, water flows through the pipe. It is flows like a parabolic path. Okay. The problem is, assume that water issuing from the end of the horizontal pipe 7.5 meter above the ground. See, this height is 7.5 meter. The height of the pipe is from the given ground level, it is 7.5 meter. This is the vertex. Okay. Water flows like this, and this is your x-axis, and this is your y-axis. This is the vertex. Water flows through the water pipe and it touches the height of the pipe is from the ground. This is ground. From the ground level, it is the height of the pipe is 7.5 meter and it touches the water, touches the ground at a distance and they are asking to find out the distance, right? See, assume the water issuing from the end of the horizontal pipe 7.5 meter above the ground describes a parabolic path. The vertex of the parabolic path is at the end of the pipe. This is vertex at the end of the pipe. At a position 2.5 meter below the line of the pipe, the flow of water has a curved outward 3 meter beyond the vertical line. See, this is 2.5 meter below the vertex and it touches, what is it? At a position of 2.5 meter below the line of the pipe, the flow of water has a curved outward 3 meter beyond the vertical line. See, this is 3 meter beyond the vertical line. The water is touches the curved distance of water is 3 meter beyond the vertical line. And if it is so, how far beyond this vertical line will water strike the ground? So this position they are asking. How far this distance of water will strike the ground from the vertex? This is our question. See, the point is 3 meter, x coordinate is 3, y coordinate is minus 2.5. Below that line, this is minus water. The parabolic path is below the x-axis. Below the x-axis, downward direction. Therefore, the equation of the parabola is x square equal to minus 4a. So this is the vertex. Equation of the parabola. Since it is open downward, x square equal to minus 4ay. The point 3 comma minus 2, 5. Minus 2.5 is our point on the parabola. Okay. Three comma minus 2.5 is a point on the parabola. Parabolic curve. So 3 square equal to minus 4a into y is minus 2.5. That is equal to minus into minus plus 4a. What is that 4? Minus into minus plus 4. 4 2s are 8, 4 5s are 10. 10a. 3 square equal to 4 into 2.5 is 10 minus into minus plus 10a. A equal to 3 square is 9 by 10 equal to your a. This is the a value of the parabola. Now they are asking to find out what is the distance of the water touches the ground from the vertical line. What is the flow of water touching the ground? At what distance the water touches the ground from the vertical line? This is the vertical line. So this point x coordinate, this distance you have to find out, and this distance you know y coordinate is minus 7.5. So you don't know the distance, you can say x1 by minus 7.5. Because y this is minus 1.5, it is downward direction of 7.5 meter y coordinate. So x1 comma minus 7.5 is the coordinate of the point on the ground. Therefore, since x1 comma minus 7.5 is a point on it, is a point on the parabola, x square equal to minus 4 a is 9 by 10, x square equal to minus 4a y. See, in this equation we have to substitute the value of x is x1 square equal to minus 4 into y by 10 into y is minus 0.75. No, sorry, 7.5. So x1 square equal to minus into minus plus 4 into 7.5, 30. So 30 divided by, so that is 9 by 10 into 4 into 7 by 30. So 3, 9 into 3. This is considering 9 into 3, 27. This is 3, 9 into 27. X1 square is 27, x equal to root of 27, that is equal to 3 root 3 meter. So distance of the water, this is 3 root 3 meter. So distance of the water touches the ground. The water touches the ground at a distance 3.23 meter from the vertex. The water touches the ground at 3 root 3 meter from the vertical line. Is the answer. That's all. That's all about the problem 8, and I will stop the video here and we will continue with the remaining exercise in the next video. Thank you.